We continue our pointer discussion. This video will discuss function parameter pointers, and we'll discuss pointer constants and constant pointers. So after this video, then we will be ready to discuss the whole idea behind pointers, which would be or is dynamic memory allocation. So for now, you recall from the function lectures that we can pass a value by reference. We create the function prototype, and let's define the function. And we set number equal to 10 here, or maybe we do number times equal to 10, right? And here we create an integer number equal maybe 2, and we call pass by reference, and we send it the number, and then we display the numbers value. We run the executable, and as expected, we pass in 2 and we're multiplying by 2, thus the numbers value is now 20, and that's what the program outputs. We can also create a pass by pointer method, and we pass a pointer to the function, and we define the pass by pointer function, and we dereference the pointer with the indirection operator, and we do the same thing, we multiply by 2. So after this count statement, we call pass by pointer, we pass it the number, and then we count one more time. So we are going to count one more time. Let me see. Let me double check one piece of information here. So we count number and line. So what should happen here? Well, number's value should be let's do 10. So it should be what? 200, right? So let's run this piece of code, and as expected, pass by reference changes the value by 10. 2 times 10 is 20, and then we pass in 200 here. 200 times 10 is 200, and this is how we could pass a pointer to a function. It's important that we don't try to do this, get the address by using the ampersand or the address operator, because as you can see, that is not allowed. So we have to make sure that we dereference the pointer. Only this will allow us to modify the value. And that's it for now for function parameters. Let's create a new directory, and pointer constants. well, maybe not there, but here. So let me set this up real quick. Create a new file here. Constants. And we include it in the project. Okay. Reload the changes. So now we are ready. So we include the IO stream so that we can display information. Create the main. Return 0. Okay. So a pointer to a constant obviously cannot modify that value. And also a constant pointer can't be modified once it's initialized. What do we mean by that? Well, we start by creating an array. So let's create an array, const integer array of 5. So we create constant size variable equal 5, and then we create a const int array set to size, and we just assign it some random values. Now we create a const integer numbers, and we get the array and we can loop through it. For integer I equals 0, I less than size, I plus plus, and let's simply count using pointer notation, numbers plus I, and we run this code. And that's good. We cannot modify the values. So what can we do to try to modify the values? Maybe numbers so let's see here. So it does not let us modify it, which is good. And then we can also create a constant pointer. So if we create a integer of 22, and let's call this number, maybe of 15, we create a const integer pointer, and we assign it the address of number, And now we're getting const here. And let me see, I think I have the syntax incorrect here, but we can fix it. Let me see, we created const int of const pointer. Okay, sorry, I had this completely wrong. Well, now we have it correct. So we cannot modify the value because we have a read-only pointer, and it makes sense that we should not be able to modify it. And that's what I wanted to discuss in this video. So we discussed function parameters, and then we discussed pointer constants and constant pointers to constant. So that will be the end of this video.